y YouTube. En el chat encontrarán los enlaces para que los puedan compartir. Y bueno, para dar inicio, les damos una cordial bienvenida a esta conferencia anual denominada Metrología para la Transformación Digital. Mi nombre es Germán Romero del Instituto Nacional de Metrología de Colombia, INM de Colombia, y los estaré acompañando como maestro de ceremonia durante estos 2 días, el primero, hoy, y el 2 de septiembre, mañana. Esta conferencia está organizada por el Grupo de Trabajo 14 M4DT del Sistema Interamericano de Metrología, SIM. Y antes
Perdón,
de
Germán, tenemos que activar la traducción. Si le das la palabra a las traductoras para explicar la traducción, porque
los silencien cuando no estén hablando. So interpretation has already been enabled. You'll see a button at the bottom of your screen on your control bar. So if you need interpretation from Spanish to English, please click on the interpretation button at the bottom of your screen, which appears with a globe icon, and then click on the English option. That way, whenever somebody speaks in Spanish, you'll automatically get the interpretation into English. Si necesitan interpretación hacia el español, ustedes verán que les aparece un botón que se llama interpretación en la parte baja de su pantalla. Aparece este botón con un icono de globo, así que por favor hacer clic en ese botón que se llama interpretación y luego clic en la opción de español, y así cada vez que alguien hable en inglés, ustedes automáticamente recibirán la interpretación hacia el español. Are there any questions? ¿Tendrán alguna pregunta? Ok, entonces yo creo que ya podemos seguir, Germán. Gracias. Thank you.
Fiona, muchas gracias por esa intervención, por explicarle a nuestros asistentes cómo funciona tanto la interpretación en inglés como en español. Y a propósito de recomendaciones, en este momento queremos informarle que es importante tener las siguientes pautas en cuenta. Uno, es que este evento está siendo grabado de inicio a fin. Los videos y diapositivas los encontrarán en la página web donde ustedes realizaron el registro. Como decía Fiona inicialmente, tener los micrófonos y las cámaras apagadas. Pueden realizar sus consultas durante la presentación en el chat dispuesto para tal fin, y una vez finalizado el tópico, el ponente o los ponentes responderán a sus preguntas. Por favor, cuando hagan sus preguntas, es importante este aspecto: no olvidar escribir a quién va dirigida. Y para aquellas personas que nos están viendo desde las redes sociales, también pueden realizar sus consultas en el chat de la plataforma. Entonces, teniendo en cuenta ya todas estas que nos acompañan para ok, y teniendo ya claro, yo creo que ya todas las personas están configuradas en los temas de interpretación. And to officially start this event, we welcome Dr. Claire Sondry, President of the Metrology Organization for the Americas, SIM. Dr. Claire Sondry has served as the Director of International and Academic Affairs since May 2007. Prior to that, beginning in November 1994, She served as the Chief of International Affairs of National Institute of Standards and Technology of the United States of America, NIST. In 2018, Dr. Sondry was elected president of the Sistema Interamericano de Metrología, the regional metrology organization for the Americas. Dr. Sondry received her PhD in biological chemistry from the University of Virginia Chemistry Department in 1989. She received her Bachelor of Science from Stonehill College in May 1984. Welcome, Dr. Sondry.
Thank you, Herman. It is a pleasure to be here today to welcome you all to SIM's annual conference on metrology for the digital transformation. As noted in the conference announcement, the digital transformation is an evolving process, and the Sistema Interamericano de Metrología, more commonly known as SIM, recognizes the critical role of measurement sciences in that evolution. As was just mentioned, for those of you who may not be familiar with SIM, we are the regional metrology organization for the Americas, one of 6 internationally recognized regional metrology organizations in the world. And our membership includes the National Metrology Institutes and their designated institutes from 32 nations established metrology working group this year. Experts from a wide array of measurement fields as it provides from different scientific and engineering in cross-disciplinary collaboration. Subjects like digital calibration certificates or laboratory automation are of interest to all laboratories in all countries in all measurement areas, and each bring a unique perspective to the subject of digital transformation. We recognize the growing importance of the digital infrastructure supporting the dissemination of SI traceable measurements. Organizations responsible for maintaining and disseminating national measurement standards are beginning to think creatively about the methods of delivering calibration results and ensuring confidence in measurement results in a world where sensors and the data they generate and the functions they serve are proliferating exponentially. Digital calibration certificates, artificial intelligence, cloud accessible data and systems, and many other innovative technologies have the potential to improve how calibration services and standards meet the growing needs of manufacturers and service providers. It is exciting to contemplate the roles metrology will play in promoting the developments in advanced manufacturing, wireless communications, biosciences, and other technologies. Progress towards the incorporation of digital measurement services and laboratory operations presents many challenges, and no one organization will approach the top designated institutes and the broader measurement sciences community, both in the public by best practices and lay the most supporting the development partners throughout the region. We need our customers. I am looking forward to hearing from the workshop speakers and considering the ways SIM can further advance research and information sharing on digital transformation. I want to thank the organizers of this event, especially SIM Metrology Working Group 14 Chair Hugo Gasca and Vice Chair Diego Copa for their hard work and dedication to coordinating these efforts within the working group and its task forces. I encourage all in attendance to get involved in these efforts to address these challenges, which are important to the measurement community throughout the world. Thank you again, and good luck with the conference.
Thank you so much, Dr. Sondri, for your word of welcome to all our audience. And with this, we officially open the conference Metrology for Digital Transformation 2021. Y ahora, en este momento, doy la palabra al doctor Hugo Gasca, quien nos brindará la siguiente ponencia, Overview of M4DT, Development in the Region and Keynotes. El doctor Hugo Gasca es el actual presidente del Grupo de Trabajo 14, Metrología para la Transformación Digital del CIM, además de colaborar como miembro activo de la Red Nacional de Investigadores Mexicanos, miembro del Grupo de Trabajo del CIM de Estadística e Incertidumbre y vicepresidente del Grupo IMECO TC6. Sobre
also in MECO 16 regarding digital transformation. He has a PhD in mathematics and statistics and has been collaborating with CENAM as a coordinator, a management coordinator, working on national standards. So please go ahead, Dr. Hugo Gasca, and welcome. Thank you. Good morning. In order to share my presentation, I'd like to share my presentation. You can do that with the green button that's at the bottom of your screen. Can you see my presentation? Yes, we can. Thank you very much.
You are all welcome to this first day of the M4DT Annual Conference 2021. My name is Hugo Gasca, and I am the chair of the SIM, as just Chairman mentioned, of the SIM Working Group 14 on digital transformation. We appreciate the welcome and opening words from our President SIM of SIM, Claire Santry. Thank you very much, Claire. We appreciate and welcome to our guests, the industry representatives and accredited laboratories from all the America's hemisphere. Also, we welcome the colleagues from the National Metrology Institutes and designated institutes in the same region and from other regions. Also to the colleagues from academia and government agencies. Today, we will have this overview. It will be very short. I already said this. So we will have 5 talks. One is about this overview, about digital transformation in the region. The next one is about the digital system of units, international system of units, or the system of units and the digital transformation process. Next, we will have a talk from, this will be conducted by several members of the technical experts of CIPM from SIM, from the SIM region. The next talk is conducted by works on Rocha from Metro, Brazil, about data mining, machine learning, and metrology. Then we will have a coffee break. And after this coffee break, we will have the live talk from Dr. transformation. There are two aspects. First of all, what does it mean, the digital transformation? We have right now several highly disruptive technologies that by their own, each one of them can do deep changes in the society. We're talking about Internet of Things, technologies, artificial intelligence, encryption, smart devices, autonomous devices, cloud technology, blockchain, digital twins, and if we combine them, the effect will be even more disruptive. And we have two ways street here. One way is how we measure, how metrology can be used to measure this kind of technologies, of the kind of products that use these technologies. And this is metrology for digital transformation aspects. The other aspect is how we use this digital transformation of these technologies to do metrology. So that's the second part, the digital transformation for metrology. And as you can see on the right of this slide, I present some basically mechanical devices to take measurements, but also there are available, and they're increasingly available, more measurement devices that are smart to implement these kind of technologies. So this is what we are talking about, and we are just looking at the tip of the iceberg. So this is a process, and the digital transformation is expected to do a deep, profound changes in our culture. So this is, as you can imagine, this is a global effort. It's not an idea from SIM. It's not an idea just from PTV or from Europe, or it's really an ongoing process. We have an effort right now at the European region, Euromed, and they have at least two visible projects on interdisciplinary metrology, the 1448 and the 1449. At SIM, we have this working group 14 in the Americas. There is also some initiatives or projects or efforts at global level from part of the CIPM that we will see later, and also from the BIPM. There are also this International Metrology Conference, the MECO TC6. They are working also on digital transformation. And this weekend, I just I got to know that there is also a starting working group at the Asia region, of the Asia region of metrology, or MRO, the APMA. And this is to be defined. I don't know the name. I don't know who is participating there, but there are many other working on these topics. So a little bit of the perspective that we have right now. At this year 2017, we have the first publications of DCC as a global project. There are some other works before this date, but there were like isolated ideas. So in this year, it is clear that there's an effort, a consistent vision for a global project to make this come true. In 2018, we have at Senam, I work for Senam, we have a strategic planning exercise as a result from an external audit to the Senam, the NMI of Mexico. And we got from there the outputs on the top, the recommendations to pursue. One of the results of this audit was a recommendation to pursue digital transformation. And then of knowledge. Then in 2020, we got the first, well, of course, you can see that we have this COVID era starting in 2020. And during this year, we have the first workshop, the virtual workshop about digital transformation. This was originally planned to take place in Argentina, and we were contacted, and we jumped into that boat and help organizing virtually this workshop. We joined this effort. As a result of this first workshop, we start building an M4DT website, and also we build up some informal working groups to focus on some of these technologies the technologies that I just mentioned, the DCC, the artificial intelligence, big data, etc. During 2021, we have this second workshop. Prior to this, we have this formalizing this working group at SIM. Also, we define the working groups were take the name of task forces, and also the whole group was formally defined at SIM. And also there is a project that is funded by the PID, and it was just approved at the beginning of this year. So I also mentioned that there are some efforts, global efforts, that affect all of us, and this is about the CIPM FAIR principles and the digital system, international system of units that are pushed here, they are put here as a reference that they were published, I would say, globally. And
the beginning, it would be a good idea for all participants to check the website on Metrology for Digital Transformation, and there you will find information about upcoming events and the presentations too. You can find this information or the link on the chat. So let's start with a question and answer session. Please remember that questions can be entered in the chat. We'll give you a few moments.
Si la audiencia tiene alguna pregunta para el doctor Gasca. Bueno, parece que en este momento
Dr. Gasca, there don't seem to be any questions at the moment, so we will continue with today's agenda. So we will move on to the first conference block on digital design. So we will listen to Edwin Kulma. He's an electronic engineer with a master's degree on with experience on metrology, and he has experience in magnitude development, continuous current, and time and frequency alternations, and he works in the National Metrology Institute in Colombia. Go ahead, Edwin Kulma. in the digital transformation process of our world. The SI in the process of digital transformation that our world is experiencing. He is the IT director at the SENAC in Mexico. He has a master's degree in computer science, and for 2 years he's been participating as an expert supporting the working group on digital SI of the CIPM. So go ahead, Francisco. Thank you, Edwin. This is a topic worked on by a 5-person group: Diego, Edwin, Francisco, myself, Mauricio, and Olman. On the event's website, you'll see a brief summary of our CVs. The 5 of us have participated in the process that led to this project in order to contribute to metrology in the region, and the metrology for digital transformation in the region, that is. So we're going to be talking about digital transformation. We're also going to be talking about SI and digital transformation in the current world. The digital transformation process has 3 steps. The first step is digitization, which is a word that doesn't really exist in Spanish, but expresses the action of copying something from the physical world and sending it into a digital world. So I can digitize my license, for example, my driver's license, and save a copy. And the next step includes digitalization, which includes the use of digital technology so as to change models digital transformation. Let's have a look at the international unit system. So this SI system comes from the implementation of measurements and focuses on the traceability of measurements using reference patterns or standards, which also uses the SIs expressed in mass, longitude, time, and other magnitudes as well. The Meter Convention is a treaty that was signed in 1965 in order to establish a global regulation, which is also considers 3 organizations in order to preserve these system standards. Now, the Weights and Measures Office in Paris, the International Committee, CIPM, the Administrative Committee, which meets yearly, and the General Convention on Weights and Measures, which takes place every 4 years with the delegates from all member states. Currently, the convention has 102 members or associate states, which are organized within 6 regions, which you can see on this map in different colors, which make up various NMIs, designated institutes, and conventions. And this represents over 97% of the global economy, as well as the basis for many global trade and science treaties. So around the world, there are over 65 or more or less 65 accreditation bodies accredited under ISO IEC 17025, which is responsible for maintaining process in order to carry the competition frameworks and to establish more efficient processes in our world, processes such as the in Latin America and the Caribbean. The digitalization, the development of technologies for improving the dissemination and training, and the development of metrological and regional processes. So through SIM, we have developed proposals in order to support the various institutes by taking advantage of experiences and rationalizing resources. So now let's have a look at digital transformation, which is something that's occurring around the world. So this transformation experience has been promoted by scientific research in order to collect, harmonize, and create knowledge. So within this field, we can see the participation of Brent Must and Mark Wilkinson. And these two people have been participating in organizations since 2003, and these organizations include the Concept Web Alliance, which are, and they've also participated in various events, such as a workshop which occurred in 2014 in order to implement principles such as the FAIR principles, which show that it's essential to have professional infrastructure so that the research data are published, also discovered and exchanged as well as reused so as to implement valuable resources such as interoperability. So with this FAIR acronym, or under this FAIR acronym, it was possible to publish principles, and it was also possible to republish them in 2015 and 2016 in the Scientific Data magazine. Mark Wilkinson briefly defines the FAIR principles as follows. The findable principle refers to unambiguous identifiers supported by searchable metadata. The A refers to accessible, clearly defined access protocol, preferably machine actionable. I refers to interoperable, use shared vocabularies, ontologies, and machine accessible format. And the R refers to reusable, contextual information allowing proper interpretation. And it also talks about the rich provenance information facilitating accurate citation. So this means that I decide whether I use these data, and it will also help me decide whether I'm going to well, it will facilitate accurate citation, and this will make it easier to use machines. So it will make it possible to use these machines with little or no human intervention. And so we will be able to use computers to manage data, and as a result, there will be an increase in the volumes, complexity, and speed at which we will create data. In 2016, the European Open Science Cloud made it mandatory to adequately manage data for all types of research precisely using the FAIR principles. However, the FAIR principles have not only been adopted by the European Union. For example, in the G20 summit in 2016, the leaders proposed supporting open science and facilitating appropriate access based on FAIR. And lastly, in 2017, France, Germany, and the Netherlands founded Go FAIR in order to support and coordinate the FAIR principles. Under this context, it was possible for the International Committee on Weights and Measures, CCIPM, in October of 2019, took on a new mission. And that was to improve support to the international system of units in the digital world under the Meter Convention. So now this working group is going to invite experts from around the world to contribute to this mission. The group is responsible for developing and establishing a data exchange environment based on global processes, which is going to be uniform, unambiguous, authoritative, and dependable based on the international system of units. And it's going to coordinate this effort with all stakeholders, and it's going to establish adequate liaisons, and it's also going to make suggestions to make the SI brochure machine readable. And in order to carry out the first task, a grand vision was defined, which takes into account a digital framework for the SI. And for the second task, an international workshop was organized, and it took place in February of 2021. So the grand vision includes the SI within a digital framework, which is made up by 3 elements. The applications layer, the service layer, and the SI core. The SI core is made up by metadata models and exchange formats as well, with basic elements that take into account values, units, quantities, and uncertainty based on the SI brochure, and within the metrology vocabulary and the uncertainty guide. So the service layer, which has been implemented by the International Metrology Institutes and the IPM, has open data, software, tools, and services which are based on the central representation of the SI. And these services allow for the data to be ready for analysis. They improve quality and reliability, and these services facilitate the analysis of the life cycle of these data. And they determine whether the data are adequate for their purpose and improve their transparency. And lastly, the layer, which is made up by the applications developed and implemented by the broadened metrology unit, take into account research which depend on the SI. The tools and the services can be used with specific domain applications, including sophisticated analysis and the artificial intelligence methods and machine learning methods as well. Stratification based on a representation of the SI core and metrological traceability guarantee reliability. The SI within a digital framework, as the grand vision considers, will make it possible for metrology data to be ready for the emerging challenges of digitalization in industry and research by facilitating reproducible data science and artificial intelligence. In addition to that, the data will be ready for a profound transition for metrological applications in a digital world. This is because the machine actionable SI is fundamental in the digital knowledge domain. And the digital certificates, for example, calibration certificates, will be machine readable, and digital twins of measuring devices and equipment will be available. The framework will also make it possible to overcome existing limitations in digital data usage due to diversity of formats and approaches. And now, once the SI units and metrological concepts are used as anchors for reliable and secure data with a low risk of misinterpretation of meaning, well, this will all be achieved. Now, moving on to the next activity, which was given to the group, which was to coordinate this effort with involved stakeholders. Well, this is what was done in order to achieve this. There was an international workshop held in February 2021. It was the International System of Units in Fair Digital Data Workshop. So there were leader organizations which attended. This was on legal and industrial metrology, international QI organizations, international associations, and scientific global associations, with the purpose of finding a common terminology in terms of digital transformation. Now, in this event, it was emphasized that the CIPM could be the most reliable process for transformation in a digital world. Now, Olman is going to explain how the following topics were addressed. This is regarding quality infrastructure. Go ahead, Olman. Thank you, Francisco. Regarding quality, international quality infrastructure, all members of the most influencing institutions work together in order to develop an adequate unit representation system. This process began in 2020 in the Weights and Measures Conference, where the update of the system was approved, which changed the way in which the definition of this process was going to be carried out. In a parallel manner, the International Weights and Measures Committee, the CIPM, proposed a working group in order to create the reference framework for the International Digital Unit System. Now, here, the entities that make up the quality infrastructure entities, so ISO, IEC, BIPM, OIML, and ILAC, made up a group in order to work together so as to develop this digital transformation process among society, industry, etc., based on the international system, which is also based on the FAIR principles. So for ISO and IEC, well, in their opinion, they believe that for the future is going to focus on clear tools for the correct representation of information based on the international unit system, and also based on access for machines, and also on the development of mass storage instrument tools, and also on the use going to on with providing information with the adequate database without human intervention. And the dissemination of the international scale is going to be provided to the machines. And this is going to be done at a different level, which is going to be fully digitalized so that it's used in an automatic correction tool for global positioning, and it's going to facilitate access without human intervention. Also, the BIPM is going to provide the international system brochure, and it's also going to provide international metrology terminology with its original formats in order to provide access to the machines. There's also going to be international access to the information saved in the system that saves information from all the laboratories, and there's going to be information to access to all of the information on weights and measures, and information related to all of the countries. Now, the purpose is also to increase or improve the quality of the weights and measure systems, and there's going to be data and metadata for the continuous use of these systems. Now, they're also working on the emission of digital certificates and software for measurement tools. And this is also to provide remote certification functionality. And this is something that's going to be carried out in the future, and it's currently being reviewed. ILAC has promoted the update of these requirements and also of these documents in order to improve these remote accreditation processes. And there's also a plan in order to improve the platform so that these platforms can be read by the machine. So now I give the floor to Francisco. Thank you very much. Thank you, Olman. Regarding science and research, which would be the following topic. This is something that was covered by three presenters: Simon Cox, who's the representative of the Executive Committee of CODATA, and he explained that there are several computer systems that manage measurement units, which can be processed by computers. Most of them have expressed that these are general systems. However, each one of them has a specific story behind them and a specific community behind them as well. And they have expressed that there are efforts underway, specifically regarding UCUM and QUDT. Now, Eric Schutz, regarding Go Fair, has expressed the work they are currently carrying out in order to generate and facilitate the creation of fair metadata. Regarding COVID-19 research. He talked about the importance of metadata in this area and how the forms that create these metadata can be used in general terms in such a way that there are various research projects that can become enriched with these metadata. So they also showed interest in incorporating science fair projects that are being carried out. Isana Jones, who works in the Open Science Cloud. Well, this is a cloud that includes fair data and services. So this allows for various research infrastructures to work together in order for them to be analyzed and overcome the challenges proposed by society. So there are authentication and access mechanisms proposed based on persistent identifiers and based on metrics through a help desk. So in this network, there are information repositories from various communities which are organized in data groups. Now, the digital infrastructure and representation of units within this context play a very important role. Edwin is going to talk about this topic. Go ahead, Edwin. Yes, Francisco, thank you. So in relation to this topic regarding industrial digital infrastructure, there were 3 presentations who spoke about progress made. So there was UCUM, Unified Code for Units of Measure, and there was the HEMIMEG 2 project by Siemens. And there was also the measurements information infrastructure topic as well, M22 specifically. So now these panelists spoke about the general description of the wet semantics, W3C topic specifically. So this is regarding RTF specifically. So now, they also spoke about the considerations of a digital framework for information infrastructure. So after the Q&A session, it is possible to say that the 3 panelists have invited the metrological scientific community to participate in these ideas and projects, and also to join in on these topics as well, and that there are development communities in these areas. And they have also expressed that there are certain elements to take into consideration, such as functionality, tools, repositories, also commercial functionalities, specifications, the recommendation values, production declarations, the tool and the this topic is something that was considered from this point of view. So now I'll give the floor to Mauricio, who is going to talk about another cross-cutting topic that was covered during this workshop. Hello, everybody. Thank you. So This topic covered up digital presentation of units, the digital presentation of units, which must be carried out under the FAIR principles. And it was also spoken about the current situation. And the following challenges were mentioned. So there are various formats when talking about units, and each format has a different way of talking about units. For example, there are cubic meters, which could be presented under different formats. So a machine can represent cubic meters, but the machine itself doesn't know what a cubic meter is and what it represents. And also, it's usual for measurement units with digital interfaces transmit their results reports, which won't include unit measures and also won't include decimals based on their measurement uncertainty levels. So considering this, it's necessary to work on a unit digital representation unit so that measurement results are also understood by the machines. In addition to that, we showed two digital unit representation systems. One was Wolfram and the other one was QUDT. Both systems work well, and there are many operations with units that can be carried out, as we can see here in this example by Wolfram, which was used for calculating area. So if we enter 3,000 meters and 1 kilometer, we can see what the results are. So we'd have 3 square kilometers. But these systems aren't fair because they don't comply with their interoperability principle. And we would have to develop these principles in order for them to be fair. Now, Diego is going to talk about what the regional organization spoke about during this event. Thank you, Mauricio. So the last topic we're going to talk about is the one by the regional metrology organizations. We have AFRIMET, APMP, COMET, SIM, and Euromet. They've expressed during this year's workshop that they're making efforts towards digital transformation or are planning to start doing so in the short term. So they've also agreed on the fact that the certificates must be digital. Therefore, it is necessary for them to be linked to the CIPM and for the CIPM to coordinate the transformation of the international unit system in the digital world. In the workshop, the regions have expressed their different opinions. For example, AFRIMET has expressed that they are working on projects which are linked to digitalization within CIPM and has expressed its region's potential for the global market. IPMP carried out a survey within its organization to understand the actions carried out and the opinions within its region towards digital transformation. And EPMP has also expressed the need to digitalize its market and its business and to express what its vision is so as to define what the new stakeholders are and its values within digital transformation.
COMET has looked at, has seen different challenges in this regard and is proposing development objectives supported by enabling technologies. And with the objective of looking into different aspects of digital transformation, they propose a working group and 6 specialized groups on strategic issues linked to digital transformation. So Euromet is the organization that has its objectives and vision very clear. This is linked, what they do is linked to health and innovation. In order to advance digital transformation, they have well-defined projects and the GCM 1148 and 1149 and ISM 2020. The fundamental element was a declaration issued by the CIPM in its preliminary version, and with this declaration we will conclude this presentation during this event. Given that the international system of units underpins all measurements in industry, trade, legal, metrology, and science, its transformation into a fully digital representation is necessary to facilitate efficient processes within industry, quality infrastructure and its organizations, in modern research and development globally. Such a digital representation relies on robust, unambiguous, and machine-actionable digital representations of units of measurement. The breadth of potential applications is extensive and is likely to grow, and progress on global challenges requires participation and critical thinking from diverse communities. Representatives from the IML and CODATA have already indicated their cooperation and collaboration with CIPM in the pursuit of the SI digital framework and its propagation in compliance with the FAIR principles. In this slide, then, we can see the regional and international representatives of the CIPM work group or the task group contributions.
Muchas gracias a todos.
Thank you all. And those who have made this presentation are available for questions.
Muchas gracias a los
Thank you to all the presenters. We are grateful to that group, and if you have any question, you can put it on the chat. Let's start with questions and answers. Then, unfortunately, because of time, we can only answer a few of them. If you require more information, you can go into the web page M4DT, which is the page where you registered for this event. So the first question. The first question is from Rodrigo Cabrera. As a user of a third-party laboratory for our calibration services, how can we benefit with this digital transformation? This was a general question for all who would like to answer. Francisco, please go ahead. Yes, I think there are two aspects that we need to take into consideration when looking at digital transformation. First of all, what do I need to do to receive digital transformation or to receive the benefits of it? And that is related to, well, if I digitize the calibration certificate, and also my processes, what will I gain as a laboratory? And the second question is, how can I contribute to this digital transformation? What I have in my laboratory, what I know, what's valuable there, how can I take advantage of my best practices to measure these activities, and how can they help towards achieving digital transformation? I think that all of us, whether we're primary laboratories, industrial laboratories, or national metrology institutes, I think we need to focus in these two areas. How can I benefit, and what can I contribute, and what can I acquire from digital transformation? So let's look at the processes that can be streamlined in your daily activities. That would be an area to look at. Thank you, Francisco, for your answer. A second question that we have here for the panel is from Luis. May evaluate risk about digital calibrations. This is a general question. Who would like to answer? I don't really understand the question. In what sense is Luis Mejia thinking? It's a general one. How can we evaluate risk regarding digital calibrations? We need to think about enabling technologies. There are information security technologies that need to be taken into account when you're doing a calibration. That would be one of the risk evaluations that would need to be made when doing remote assessments. You need to evaluate what enabled technology is being used, and based on that, what risk evaluation you can carry out regarding the technology being applied. So if it's in the cloud, happen in blockchain or each represents, or if it's in the risks. Thank you. You mentioned ILAC. Project by ILAC to standardize the CMCs of accredited calibration and testing laboratories according to FAIR criteria. This is a question from Francisco Garcia. Who would like to answer it? I think regarding ILAC, well, we did speak about what they're doing. And I think it's not directly related to CMCs, but Olman did mention this, so maybe Olman would like to answer this question. Thank you. On this topic, then, during the time of the presentation, ILAC was speaking about all of its updated documentation and access to this documentation. But from the point of view of the CMCs and PPM, as many of you know, they already have a platform for access and for documentation on CMCs with an already established structure. This is a new platform because the idea is to provide digitalized access to this syntactic structure of the information so that any machine or any search engine or tool can access this information and use it. Maintaining the information secure, carried out by ILAC for the BIPM capacities in their database. So it's joint work in order to develop these tools digitally so that they are accessible without any human intervention. So that's basically what we were saying. Thank you very much. And then to conclude, we have a comment from I think that each supplier to digital certificates. We have 3 questions then, and this comment from this panel. Just one comment about what Fernando said. The DCA applied to the CCA is one of the cases that is applicable. You can think of other types of cases as well, but the DCC is one of the cases only. I just wanted to make that short comment. So thank you to the presenters for your excellent presentations and for answering the participants' questions. So with that, I will pass the microphone to Germán for the next block of the agenda. Thank you very much. I'd like to thank the engineers, Gulma, Flamenco, Ramos, Parini, and Diego Copa for these excellent presentations. And now we will continue with the next block of presentations. This
is the interface with metrology. Dr. Werkson is a metrologist with particular expertise in data science, machine learning, data mining, chemometrics, experimental design, exploratory data analysis, graphical communications, interlaboratory comparisons, measurement uncertainty, and quality assurance control. He did his PhD and master on data analysis at the University of Campinas. He is advocated for research and development at interface measurement science and data analysis. Go ahead with your presentation, Dr. Erickson Pasha. Thank you.
I thank you. Can you hear me, everyone? I think so. That's right. Okay. My name is Werkson. I work at Metro, and my presentation is data mine, machine learning, and data science. What is the interface with metrology? Just 1 second. Basically, I'm showing this slide. Who am I? I did chemistry, and after I did 2 master in data science, and I had a PhD in data science too. After that, I went to NIST. I was there like a guest research. And the first time that I was at NIST, I worked in the statistical division. And the second time, I worked there at the chemical science division. Basically, the second time, I worked with machine learning, applied chemical and biochemical data. I started to work in Metro in 2010, and my main interest is the use of machine learning method and metrology. Here, my presentation, I split in 6 topics. First, I'm going to talk about some definitions. I will talk about data new goals. I will talk about generate trust data for machine learning. I will talk what does the data say, and I'm going to give you some examples, and I'm going to conclude the presentation. First definition is the data mine. Data mine refers to the application of algorithms to extract pattern from data. Basically, here I put 2 basic algorithms that we use. The first one is PCA, Principal Component Analysis, and Cohon or Serve Organized Maps. Here we can see in this picture different class, different colors. And for this data, we can use some kind of data mine algorithm to understand that. In this second figure here, we can see 2 classes for the data. We get one data, we can extract the information from this data, and we can see 2 groups. In this case, the green apple and the red apples. And this third figure, we can see 3 groups. And in this last figure here, we can see, depend how I look the data, I can see 3 or 4 groups. This is the idea about the data mine. Use some algorithm to try to find some pattern from the data. Machine learning definition, it's very important too. Basically, to understand machine learning, we have to get some data and to create the model. The first step we call building the model. After that, we need to validate the model. Basically, we need to test the model. When we test the model and we create the model, we can say that we have a good model. It means that we can use this model to understand unknown samples. Let me try to show you in the figures. The first step, we need to build the model. For example, you go in the lab, take some measurements. For example, you can get some spectra and you can do the correlation with some property. For example, if you think about sugar, the concentration of sugar in the soda, and I can take some measurement in the lab, and I can do this correlation. It means create the model. The model will give me the correlation between this measure and the property of interest. In this case, I said concentration of the sugar. When I do this, after I have to test in the model. When I test the model, I get non-samples that I can see if I get the correct results. Basically, I have two steps. The first step, building the model, and the second step, testing the model. After that, I can use the model to unknown sample. Here, basically, we have 100 samples. Let's think in this way. We have 100 samples. We separate, we split 17 samples to build in the model and use 30 samples to test in the model. When we see, we check the statistic of this model, we can say, okay, now we can use this model to try to understand unknown samples. It's me applying the real world, applying the model for unknown sample. For example, if you are doing this for concentration of sugar in the soda, if somebody else comes to you, give the soda, wants to understand the concentration of sugar in this soda, you get this soda, put in the lab, run a measurement, put in your model, and your model will tell you, okay, the concentration of this soda is this number. This is the idea about the machine learning, okay? And the first step here that I highlight, it's the learning process. The learning process is very important. And the second, the next is deep learning. Deep learning, it's basically a subset of machine learning. If you look here, basically it's machine learning, but we have the complicated algorithms. Like we have many layers, we can see many layers, many multiple number of nonlinear transformation. It means complicated equation that we can predict some properties. In this case, I put here some label thoughts. For example, cat and dog. If you put a cat, put in this model, the output, in this case, get cat, got correct, okay? This is the deep learning. Another definition is important, and it is artificial intelligence. If you look in this video, the machine is jumping when data mine definition. And here's the last definition is metrology. Everyone knows. I took this definition from BIPM. Basic metrology is the science of the measurement. The idea for this presentation is show to you that we need to do good measurement with metrology, and after that we do the data analysis. With the data analysis, we do machine learning. We use all these different algorithms to learn, to understand what the data says. Okay. Another thing is data. It's considered nowadays like a new gold. Data is considered nowadays as the new gold. Why? All the time in the lab, in the industry, and in the company, we create a lot of data. But you have a lot of amount of the data, but you need to understand, you need to get the information from this data fast. To do this, you need to create good machine learning and get this information. When you do this process in the correct way, you can extract the information, you can extract this gold from the data. This is why we say nowadays the data is new gold. Some example that I put here. Farmers are using data from seeds, satellites, sensors, and tractors to make better decisions about what to grow, when to plant, how to track food fresh from farm to fork, and how to adapt to change the climate. This basically, we got the information with all this sensor, we put this information in the cloud, and we can make a decision about this information. This is very important in agriculture today. Another definition, it's very important when we talk about many different activities, reference data. Reference data basically is the data that we can trust. For example, when we want to learn how to use a machine learning method, for example, PCA, we need to get one data that we can trust. This data can be a database come from the Institute of Metrology, can be the data from one company. Basically, it's the data that we can trust. When you do this, we can give this data to somebody else, and this somebody else can use this data and try to understand what the data says. And how can I generate this reference data or trust data from machine learning? How can I obtain this data in the lab? Basically, we need to get trust measuring. We need to use appropriate instrument for the purpose. We need to use calibrate instrument. We need to take people understand how to use the instrument. It means trained operator. We need to use, for example, reference material, standard reference material. When we do this in the correct way, we create good data. This good data we can label in trust data. And because we have trust data, we can have trust machine learning. We have trust model. It's mean good data in, good data out. If I put bad data in the model, I'm gonna have bad data, bad results. It means here that doesn't matter if your data, the data, if it's bad, the machine learning is not change this. The machine learning is just try to describe the data. The machine learning is not change your data. This that you need to understand here. Here I put, if you remember in the last slide, building a model in machine learning, if we have trust measurement, we are gonna have trust model. Here I put this report, very famous. Somebody else, psychologist famous, he took fake data and put in the model. The model will give the answer, but the answer is not correct. This I'm trying to say about to create trust data. Trust data, it's mean reference data. It's very important for machine learning because you can use the model and you can trust the results. Basically here, we got all this data in this kind of tables. In this kind of table, the data comes from food, chemical, environment samples, pharmaceutical samples, doesn't matter. In the rows, we have samples, sample 1, 2, 3, or replicate. In the column, we have the variables. For example, wave number, retention time, pH, qualitative numbers. Basically, in the rows, we put the samples. In the column, we put the variables. When we have this table, we put this table in the machine learning, and we can create the model. What does the data say? When you do this machine learning process, we need to ask some questions for your data. For example, if you are study biological sample, you can ask, is the person diabetic? You run your experiment, you try to answer this. How many soils are there? You run your experiment and try to answer this question. How much sugar do I have in my soda? Basically here I'm saying, when you create the machine learning, you need to get the data, ask you one question for this data, and try to answer this question with the machine learning process. Now I'm going to give you some examples that I have used some machine learning. The first one, it's a work of the properties, I mean the physical chemical properties from these samples. And now we can create the model. Basically, we have the GCMS data and we have this reference data. I mean, we have physical chem properties, we have density for all the samples here, many different SRM and real samples. We have values of density in two different temperature. We have viscosity in two different temperature. We have pour point, as number, and base number. Basically, here we have different properties from different samples, and we have GCMS data. And we created the correlation between GCMS data with all these results. What is the idea? When I create the model and I put the new GCMS data in my model, the model will give me all these properties, and I don't need to use the ASTM method. This is the idea for this work. And here some results. In this case, we use two algorithms. The first algorithm calls PLS, it's linear model, and the another one SCVM. Here's the example for model 1, model 2, for one property, second property, third property, and for another property here. The conclusion for this work, basically linear and non-linear methods with the uncertainty can be estimated um, uh, physical properties of fuels using GCMS data. The properties were measured using ASTM standard method. It means that I got my reference data from ASTM standard methods, and PLS and SCVM were used to determine a relationship between the GCMS data and the measuring properties. Another work we did, it's about the same samples, but we try to classify these samples. Basically, we have a biodiesel sample and different kind of petroleum samples. The idea is, the objective of this work is to build chemometric models for unsupervised classification of transportation fuels using GCMS data. Basically, here's the table of all this data that we used, and now we have some results. In this plot here, we can see here two groups. The first group, this sample here means biodiesel. The second group here means petroleum. If we look inside the petroleum, we can look at this plot here, and we can find the small group here. Inside this small group, we have jet fuel samples, JP5, JP8, and J fuel A. And we have three SRMs inside this group. And we try to understand how these samples are there. If you look at the composition for this SRM, they have the similar composition of this jet fuel class. This is why we got together this SRM. Basically, the composition is the kerosene and aliphatic. This is why we got this SRM inside the group jet fuels. This is another data analysis. It's called Cohone. We call here U metrics, and here we call this distance metric. Basically, we have two different visualization because we did two reference materials that tested with many fuels class. Also, many classes were properly differentiated through pattern recognition by MPCA and Cohone. Another work we use of multivariate statistical analysis to evaluate the experimental result for certification of two pharmaceutical reference material. In Metro, in general, he does this kind of SRM. in pharmaceutical area. And another idea for this work, it's the intention to encourage metrologists to apply these machine learning methods in your activities, like production of SRM in the interlibrary compared. This is another idea for this work. And here for the drug one, the metronidazole. This is the data from homogeneity study for the production of this SRM. Here we can see two groups from the drug metronidazole. The group A1 diverged from the main group. We can see in this picture here, and we can see in this picture here. This A1 here means these results here. Basically, here we have two groups. For the pharmaco 2, for the drug 2 captopril, it's the same idea. We have two groups, and this group here, the small group, we can see in this picture here. In general, when you do this standard reference material, we do the calculation of standard uncertainty for the homogeneity. In general, people use all data points. If you use all data points, you get this uncertainty here. If you use this machine learning method, if you use this algorithm, you can reduce the uncertainty. For example, for the metronidazole, around 50%, if from the second drugs, around 2%. Basically, here we have been we used this algorithm to do outlier detection. And when you do outlier detection, we can reduce the uncertainty for this data. This is the idea. Use the PCA and HCA, it's kind of a clustered analysis to try to detect outlier in the data. With data in the homogeneous study for this kind of drugs. After the pH of fused ethanol. Here, what is the problem in this work? There is ASTM D64223. I don't know if you are familiar. Basically, they say that we have to use to determine, to find the concentration of the PAD of fuel ethanol, we have to use the electrode called Orion, this A here. But we try different electrode, and we can see here the electrode D and B in this figure here, and in this figure here, A, D, and B, they have same results. It means I don't have to use the electrode A. In the ASTM, they say you should use the electrode A, but we can prove with this work that we can use another electrode and they have similar results. This is the idea. We did one big work with a lot of different colleagues, different universities, different institutes to try to create a protocol to do data analysis in metabolomics. Metabolomics in general, it's very difficult to find the same metabolites because, you know, every person is different. We produce different metabolics, and this work we try, okay, let's create a protocol that the people follow. We can find some metabolites and we can find the same result. We can try to create a standard for these people. And here now we have the project at Metro to build in software for metrology. All this algorithm that I showed, we are now doing some software to put this web application for people use. This is the first software. It's not online, but we are working to put this software online soon. And in this software here, all this paper that I showed, we can reproduce the results. We can do univariate analysis, we can do categorical analysis, and we can do multivariate analysis. The multivariate analysis comes from the algorithm that I showed in 2 papers early. And the conclusions, data science methods have been used in metrology activities in order to transform complex data into relevant information. There are several applications that use data science methods to perform metrological activities that provide better understanding of the results. I would like to thank you, the scene. Thank you, the co-work Rodolfo. And I would like to say more one thing. We have one project in machine learning, and we are looking for NMI. They have people work with machine learning to collaborate in this project. Basically, we have the team of people from Inmetro, Senan, INT, and NIST. If you want to join us to understand better about this project, you can contact me or Rodrigo. Rodrigo is some machine learning to understand. And now I don't know if you can take about the machine learning about intelligence, because thank you.
Thank you, Dr. Erickson, for your presentation. We have a couple of questions already. We are late on the schedule, so I will read the first one to you and ask to answer quick. And other questions Erickson will could answer by email after this event. The first one is when we test a model, it is always advisable to do in a proportion of 30%, from Luis Suarez. Okay.
Okay. In general, we can have some book they say that, but it's not a rule. Okay, you can depend about the data. We can use 80% and 20%. We can use 7%. It is not the magic number that we need to follow. Okay.
Okay. There is another question from Fernando. Could you shortly explain why did you choose PLS and CVM for the first example?
Okay, basically PLS is linear method and SVM and non-linear method. We have different properties and we don't have idea how it's the relationship between the GCMS and the properties. And this is why we choose linear and non-linear method to see, okay, which property works very well with linear method, like in this case, PLS, and we want to try to see which properties works very well with SVM, non-linear method. This is why we choose 2 algorithms, linear and non-linear method. And there in the paper, we put it there. In the presentation, I couldn't put all results, but there we can say some properties, they work very well with the SVM. It's mean that property it's non-linear. This is why we choose just 2.
Okay, another one. It's possible to use the same algorithm principle to treat data obtained from different techniques?
Yes. Yeah, you can use you get, there is in the data analysis one thing called data fusion. Okay, you get different technique, different instrument. For example, you need to get 10 samples, okay? 10 sample, you run this 10 sample in the lab, in the machine 1, in the second lab, or in the same lab in the machine 2, and third machine. It's we have different kind of information for this sample. We can merge this and we can use the same method to try to understand the problem that you have. Basically, the answer it is, you can.
Okay, another one. From your point of view and expertise, what is the gap or challenge to implement AI, machine learning, DM, etc., with the NMIs?
This is very, very good question. When we wrote some papers about that, in general, people think in the univariate way. They think, okay, we need to do all this analysis with only one variables. When you work with machine learning, we need to think out of the box. We need to get this multivariate data because the word nowadays is multivariate. You know, you have a lot of variables of all the time for one samples, and we need to understand better with all this machine learning. Basically, we need to start. Basically, this that I have been doing, and Metro people at the list have been doing this all people think. Like, and that box.
That are then combined with the uncertainty associated to the algorithm
We can
itself.
create this diagram of the fish diagram, and we can, for example, when you have the reference data, the uncertainty came from the reference data. For example, the example that I gave from ESTM method, we have the values of the properties, and the uncertainty from this value came from the method. For the model, we can do the answers by bootstrap. It's very common we do bootstrap. It's mean we generate different samples and we can generate the uncertainty and we can calculate the uncertainty. We have 3 or 4 papers already talk about the bootstrap is the way that we can calculate the uncertainty in these algorithms, okay?
Okay, thank you very much, Wellington, for your presentation and your questions. Which I say good and leave the floor for German to continue with the conference. Thank you, Wellington. Okay, German, it's you.
Thank you. Gracias.
Thank you, Dr. Talking about this the question in this session. Who wants to add There are still a few cameras missing. I can't turn my camera on, Herman.
Francisco, creo que hay algunas personas, como escuchamos, que tienen dificultades para encender su cámara.
Francisco, I think there are a few people who cannot turn their cameras on. So we're just taking a few photographs. So just give me a moment, please.
Un momentito. Una más.
Just a moment, one more. Because we have 7 pages times 25, that means we have 175 cameras on screen.
Muchas gracias.
Thank you. Thank you, Francisco, and thank you, everybody, for your collaboration. You can now turn off your cameras. We're going on a 5-minute break, so let's be back at 53 minutes past the hour. Dr. Hagel, B2B Germany, and the Digital Calibration Certificates Group. So we will see.
And sanitation. times an uncertainty. You have constants, and you have no uncertainty. So here is a link. Just look for what we just use. And it is possible for us to change here to another format, but we just at the moment use this digital SI format. The second important basic is that we use a hierarchical structure for the DCC. There we just look very intensively to the 70.025. First of all, we have the administrative data. This part is completely regulated. What is it in this part? That's a typical first page of an analog calibration certificate, where is written who makes the calibration, what is the item, when was the calibration done, and so on and so forth. These things are on the first ring here. Then the second ring, the results of calibration, they are sometimes regulated. They are in a partly regulated, because we say please use SI units. Please don't use such thing like Grad Oechsle, which means the density of sugar for the wine production. It's a German unit. Or please don't use psi for the pressure. Please use the SI units. It is possible. It is not so complicated to use SI units. You can do it. And because then if you use SI units, then you don't have any mismatch. What cannot be regulated is another point, is that there are so different items to calibrate, so that the results or what we do to calibrate this is totally different. For example, if you look for a calibration certificate out of the area of acoustics, it is totally different to the area of the mass. Or it is totally different if you look for cyclotron beam. So you get a huge split of various calibration certificates. It's a normal in the analog way and in the digital way too. But what can we do to get here calibration certificates are not only machine readable, but also machine interpretable. It makes no sense that they are able to read it if they can't manage it. So it is necessary that you go to the communities and that you try to find out a way how you can make calibration certificates for different items. Okay, then there's the third ring. The third ring means that you can put everything you like inside of this container, of this XML container, which means that you can put, for example, the bill for the calibration or the insurance for the calibration here inside of the ring. So here you can take everything you like, which has nothing to do with calibration. Or you can take an old format for the transfer of the data, which has been established, which is established for a longer time. Then you can use this here too. And the fourth ring is a human readable document. What is mandatory? Mandatory is the first and the second ring. These two rings are mandatory for the calibration certificate. Ring 3 and ring 4 are not mandatory, but you can put them on. Okay. Now we come to the third important part of the digital calibration certificate. It's XML as an exchange format. Why do we use XML? Well, first of all, the calibration certificate is a document. And there is text, or there are formulas, and there are a lot of data sets inside of a calibration certificate. And the optimal XML as these three basics, then you get the DCC. Take a look on the national quality infrastructure, because please, calibration, it's not the calibration for ourselves, it's a calibration for the industry. Yeah, that's where the benefit, last but not least, is to be seen. So everything is done for the consumers and for the general public. And how can we do this? How can we bring this to the customers and to the general public? Well, it goes via the enterprises, via the companies which are very high efficient. And now just look, what are the basics for the quality infrastructure? This is from Gulasch et al. From the World Bank in 2007. But it is valid today even more than before. Here we have the three basic institutes. It's the National Metrology Institutes, the national standard bodies, and the national accreditation bodies. They are important for the structure, for the infrastructure. And then we have here the calibration laboratories, the testing labs, the inspection bodies, and the certification bodies. And these all together just play together. First of all, the definitions of the units are sent here to the national bodies, standard bodies, by the National Metrology Institutes. That's our job. Then you see that the accreditation body standards are given here by the national body, by the national standard body. And the national standard body does not only give standards here to the national accreditation body, but also to the others, which are here shown in different colors, and to the enterprises. And then the accreditation plays a big role, because these calibration and testing and inspection and certification bodies should that they are concerning well, then you get the benefit here for the consumers and the general public if you use the national quality infrastructure. And now we just make the digitalization, not digitization, but the digitalization. And what will happen? First, here we use the digital SI system so that we are able to make a transformation for fair data or other things which are very important. I think Francesco has shown it in his lecture quite nice and very, very importantly. But the second point is that we have here the digital calibration certificates. And if we use this here, then we normally increase the quality because here no mistakes are possible anymore. That's the reason why the digital calibration certificates plays so an important role for the industry, for the enterprises, and so for the customers and for the general public. That's my opinion concerning the DCC. Now I would like to jump to the cryptographic protection methods. Here you see the container, the XML container with all the informations. And then you can fix the informations and make them secure and identical and authentic by digital calibration certificates. And that's these are things which are since a long time in use. It's not a terrible thing. It is easy to use. It is more than 10 years in use. For example, in Germany, it's nearly 20 years in use. It's used for the civil register office. For example, if somebody was born or he marries or whatever, then this is signed by electronic signatures and XML. And the importance of these personal things somebody would like to manipulate it. These are very, very secure systems, and we use them for the digital calibration certificate in the same way. It is very easy. And please, register office, these guys, they are no specialists in cryptographic workers in the office of the government or in the town wherever they are working. In Europe, we have a good opinion because there we have a directive which says that these mechanisms are valid in all over Europe, even in Great Britain or in Switzerland or even in Liechtenstein. There, these things are always valid through the whole Europe. But we don't know really how the regulations are in other countries. So it would be very interesting for me and for our team to know how it works in your country. Now I would like to show you the DCC story. Well, everything starts in 2017. Then here the DCC starts from the on the block, yeah, here in the middle of 2017. And we have the first national DCC workshop at the beginning of 2018. And then in the middle of 2018, the first big project starts concerning the DCC. It's an Ampere project where not only European NMIs are involved, but also other NMIs, for example, from China or from other countries. And then we start an industry project. It's called GEMIMEC 1. GEMIMEC is means Gemini for Digital Twins, Metrology Global. And that's a short project to look for the necessities to find out for a huge project, for a lighthouse project. Then we have the second national DCC workshop. And then there starts another project. It's called ESAN, International Standard Accident Number, because we find out that with the mechanisms of the DCC, it is possible to use this to manage healthcare much more efficiently. If you just look for modern cars, there are a lot of sensors inside of the car. My car is about 7 years old. It's a small Ford. And he has about 50, not 15, but 50 sensors. And if I will have an accident, the doctors in the hospital are able to know what will happen to me if they know what these sensors just say. But nobody uses these values. Yeah? Data mining is important. So if we are able to send all these informations in the right value to the doctors, they know what has happened to the person who is sitting in the car. Or if you just look for, there are a lot of sensors, you can use them also. And that's what we do in the lighthouse project GEMIMEC 2, which was produced starts in August, in October 2020 with were established. What's about the participants? Well, here in these conferences, we have accreditation body, but mostly calibration labs and national metrology institutes. Even the industry was there, but maybe not in the amount I would like that they are there. There are more than 700 persons from more than 100 nations at this conference, at this first international conference. And some of you always are on this conference. And here you see the participant distribution of this DCC conference. Here in for the continents, and also for the amount of money which they earn in the middle. You see here in Africa a lot of people, Africa is not is a poor continent. Everybody knows. Here you see there's big interest even in the DCC, but also in America. And you see that many people here which are now at SIM are participating this this project. Also in Asia, in Europe, and in Oceania. So many people just listen to this international CIPM. Most important result for us was that they would say that this as a front man of the digitization. That the DCC is not always for the national, that's always always in an international focus. Now I would like to show what has happened in the near past and what will happen in the future. And first of all, you see that we just make a lot of work concerning good practice examples. And there was a very nice proof of concept in the pharma industry. They do it for the temperature, and they create a good practice example for the temperature. And that was created with a new version of the DCC version 3.0. And we will guarantee a long-term availability for the version 3.x. That's very important for the industry partners, because they need a system which is which will not change in the next 1 or 2 years, so that they can explain how to work with this. Well, the industry partners here, they just make a chain from the calibration lab to the customer. So the calibration lab produces a DCC for the temperature, and they adapt it in their system so that they can work with these calibration certificates. And why do the pharma industry has such a big interest in this? Because they say we will earn a lot of money when we change from the analog calibration certificate to the digital one, because we don't we get all the benefits by the digitization, but the digitalization is the most important part because of the quality management. They have the pharmaceutical industry is very in the focus of the quality systems, because if you look for medicine, you know, it is very well controlled by quality systems and even by the government. For example, everybody knows the FDA, the American go through on this way, and the ideal version is that you can read it into your mother tongue, but that's an idealism way. Now we are just working on other good practice examples for the pressure, for the humidity, for the flow, and we have had some other points for distance blocks, for examples, or for optical instruments, and that's something where I can tell you about 1 hour or 2 hours, but I have only half an hour. So please just check there that we have here, that we make a lot of things about good practice, and that we try to get standardization via the DKD, the German calibration service, and those that we get these standards for example, for the temperature. And then we start the evaluation of a uniform syntax for digital certificates. Just please think about it is not only necessary to have a DCC, but it's also necessary to have other digital certificates, like a certificate for the for measure it at 30 degrees, for example. And now we find out that second DCC conference, and we have now fixed data for the second DCC conference. In a few days, we will send around an invitation or the remark for this. It will be in the week number 9 in 2022, when we will make the second international DCC conference. And in the week number 24 and 25, we plan a DCC summer school in Germany, in Brunswick, where interested people can come to us and where they can learn how to work with these good practice examples, so that they are able to make the transformation to their company or to their NMI or to their calibration lab. And so if we get all these feedbacks here from what we just reached now here, we would like to implement the new version DCC 4.0 out of that what we have learned here in this part in the discussion, and I hope we get a lot of informations. How can you get more informations about the DCC? Well, how can you get downloads, development platforms, FAQs, good practice, links, miscellaneous videos, wiki or XML informations? Well, please just write down this link. It's easy. It's the normal web page of the PDB, and then you get more information. You will find, because many of my team are now in vacation, and they will come back next week. And I think at the end of the next week, you will see this layout, and then you will find a wiki and XML videos and downloads, which you can use at the moment. And the other points will be added more and more. Very important is the development platform. We will change our internal development platform in the next few days to an international open development platform, so that everybody in the world can go to this platform and need not to be registered at our moment, at the moment used development platform. So please wait about 5 or 10 days, and then you get access here to the development platform, and you can download data sets, or you can make a discussion, and so on and so forth. And now I would like to show you something about the parts which will be available when our system administrator comes back, and when he just makes this this interface, when he just prepares it. And therefore, I would like now to show you some informations. The start page where you get the wiki informations will look in this direction, but it will be translated into English and afterwards into other languages. But at the moment it's only in German, but it is easy to join to others. And then you just see here there's a video platform, there's the structure, infrastructure, and so on and so forth. And I show you now how it will look like if you go to the video platform. If you go to the video platform, you will find a lot of videos. For example, here the fundamental architecture of the DCC. That's a video which will be explained at the EMICO conference, or which was explained at the EMICO conference yesterday. And if you just go here to this, the digital calibration certificate, that's the main lecture, then you get this picture. And if you just go here to this symbol, you can see that there are captions. These captions can be, you can use Portuguese or Russian. And here you see the symbol for the excursions. For here's a small man with a net, and he tried to cache the DCC, so it's an excursion. Yeah, and there's, for example, an excursion about the production cycle, or about the unique identifier, or about the measurement results. So you get a deeper look inside of this. And as you see, there are other videos, for example, for the digital SI, you see it here. And here's a video concerning GIMIMAC 2. And here is a video of our president, Professor Ulrich, concerning the global challenge in metrology. I think these are interesting videos. So if there's no go to our website and look at it. And the next point I would like to here you can see what build it up. And this is and you see here the 4 rings I've shown to you, the administrative data, the deeper information for those who are a little bit just look about the attributes and about other things. And for example, if you go to the child elements of the DCC, of the digital calibration certificate, here you have the administrative data. If you click on it, then you get the structure of the administrative data. And here, for example, we can look for calibration or for core data. Then you see all these things which are necessary to know about, for example, begin performance state, end performance state. These are things you have to write down in the administrative data block. So feel free to go to this website. I think it's a good idea to wait for some days and just check it. And yeah, so please feel free to go to the site. And I hope that in the next few days we will get here much more information. So thanks a lot for your interest for this talk. And yeah, if you have some questions, please feel free to contact me.
Thank you, Dr. Hackel, for this excellent presentation. There is a lot of information about the DCC, some of us news, so thank you very much. So now we are going to continue with the second talk about the DCC. Now I present to the engineer Itzel Dominguez, who is hold the conference titled DCC Development at SIM. Itzel Domínguez es ingeniera en sistemas computacionales. Se desempeña como analista programador en el Centro Nacional de Metrología de México, en el CENAM. Tiene amplia experiencia en el desarrollo de sistemas de información y actualmente forma parte del grupo de mejora de procesos y de certificado digital dentro del CENAM. Por favor, adelante, Itzel, con tu exposición.
Buenos días a todos. Yo les voy a hablar sobre los avances que se tienen en 3 NMIs, que es el NMI de Perú, el NMI de Argentina y el NMI de México, nosotros. Entonces vamos a iniciar con el INACAL, Perú. Es con información proporcionada por el ingeniero Rubén Gil. Primero, vamos a ver el estatus actual del INACAL respecto a todo su proceso de calibración, desde que el usuario solicita ese servicio. Vamos a verlo de manera muy breve. Ellos tienen un sistema de citas metrológicas en web, donde el usuario solicita su servicio, después lleva su instrumento para las mediciones. Ellos cuentan con otro sistema interno que se llama Metro, donde se proporciona un código por instrumento y de esta manera se puede rastrear todo su estatus durante el proceso de calibración. Después se realiza automático manual dependiendo del genera una plantilla el cual también se firma de manera electrónica.
Now, in a more detailed manner, this metrological appointment system services are grouped by magnitude. One wire, they can also select the date on which they want the service to be carried out. And the calendar is linked to the laboratories based on the work that's going to be carried out. And with that, they can select the dates when they want the services to be conducted. So these services are reserved for 24 hours until the payments are made. If the payment is not made, the reservation is deleted from the calendar. Once the process is finished, a quote is provided in order for them to make their payment, and the payment can also be made online. And once this is carried out, they receive an identification code, which they can use to consult the status of their services. It's extremely important to mention that in order to receive their digital certificate, the automation of calibration services is extremely important because that's what they use in order to obtain their certification, or that's the process through which they obtain their certification. And INACAL has many automated services which have been developed by INACAL personnel with LabVIEW. And what they do is that they take the information from the calibration process and they enter it into the Metro system, which generates the Excel file, which is used in order to create the PDF document. Now, the laboratories with the highest number of automated processes are liquid flow and organic chemistry, energy, potent, and gas flow. The Metro system generates a single code for each device, and with this, tracking is carried out through the calibration process. The system also provides warnings for calibration frequency for the various standards in order to program services and for carrying out statistical reports and for generating the Excel file. Once the PDF file is generated, it's signed electronically, and this electronic signature is supported by the National Identification and Civil Status of Peru, which is an autonomous body in Peru, which is responsible for identifying the population in Peru. And the following steps which they carry out for carrying out their their digital certificates, the first uses a program developed in 2020. And this process detected certain needs within their laboratories in order to carry out more automation. And they've also developed a system which receives the information regarding the automation processes um, in order to avoid them from having to provide more information directly to Excel. What they do is that this system generates the XML for the digital certificate based on the standard established. And they also have to make certain modifications to their Metro system in order to be able to integrate their electronic and in order Argentina with information for 2020, there was a survey carried out among metrology laboratories within INTI in order to learn about how they process their calibration data and how they generate their certificates. So based on the survey, it was observed that 60% use the calculation sheets for processing their data, and 80% use text processing software such as Word for generating their final certificate. So once it was determined that what the SEC standard was, they made the following proposal. First, that they should continue using these Excel spreadsheets in order to avoid laboratories resisting the adoption of new technologies for the generation of certificates. So they're going to be developing a Python solution because this is a widely used language that also has many tools for everything that we're trying to do here for generating the XML, the PDF document as well, a web server, etc. And so what they would be doing regarding these spreadsheets would be standardizing them so that the systems they're going to be developing can process them adequately. So they're going to be using the generated DS tool, which provides Python. So the XML scheme is transformed into various classes within Python, and so that with this, well, they can use a process by which the programs are created into various classes and the things that can work in a more streamlined manner. And in order to create the PDF, they're going to be using XSLT and LaTeX. And LaTeX is a tool which is very good because it allows us to generate documents with symbols. So in this case, for example, in the digital certificate, many times we use mathematical formulas, and LaTeX, for example, in a very simple manner would allow us to integrate or allow them to integrate those formulas. And in order to ensure those XML and PDF documents are going to use the Django as a web server in order to manage and maintain these files. So they are making this proposal in a very general manner, just in case there are any other NMIs that would like to adopt it, because they can do it if they wish to do so. So this is something that they're proposing in order to carry out these processes and to reach these goals. Now we're going to see what what SINAM Mexico has done. And we have created a group in order to develop this digital certificate. So first of all, our current situation is that our certificate is now generated through a web server where, first of all, we request the service number, which is a single identifier number. So with the database, we bring in what we call the administrative information, the client data, the team data. Then what we do is that we request the user to give us the dates when the calibration was carried out, the location, the validity date, for example, who's responsible for the calibration, who's going to be approving the document, and we ask them to upload two files. One is the document with the results, which have to be in a PDF format and with certain established margins, and the document or the file on the calculations. This could be an Excel, it could be a zip file, a PDF file, a docx file. So once this information has been provided, what we do is that we sign it electronically with an internal use signature within SINAM, which we call it the CAD signature. And this is basically a password for carrying out certain procedures. So first of all, it's signed by the person who carried out the calibration, and it's then signed by the person responsible for approving it. And as a result, we obtain a single file where the first page provides the administrative information, and we then add to this the document with the results uploaded by the user. Once all of this information has added to one file, the pages are numbered, and each of the file's pages are to each of the pages, we add the number of certificate and the service number as well. So now in relation to the generation of the BCC, we have two paths. One would be through our web application where we develop an ASP.NET and through a desk application with LabVIEW. So now through the web, what we do is, well, this is very similar where we require the service number so as to begin the process, and we include the information we have available. And this is organized based on the BCC. So what we do is we have two areas where we add the administrative data and the results. Each one of these areas has a subsections, and we've already completed the calibration processes, and easily generate the XML document. It's a tree of SINAM to then send it to the client or manage it somehow. Our current and future work. So we are currently working on how we can better add our results into the web system. So we have three options. One, the manual entry of data into the system by establishing information such as the unit, etc. Second, through an Excel file with a defined format. And third, through an XML document containing the PTB format only, which could be an XML generated on the desktop version, which we would then add a page such as the first page on the other documents we showed you. So these would be the proposals on how we could develop a form for the Excel file, because we have various tables here. So the system locates these tables and then would know, okay, considering the structure we're using, would then know, for example, we have this element here, which is the name, and then the information included under this element. And for example, this would be another proposal which would refer to the calibration results, where we would have to include information such as the heading, the unit it refers to, and then the information. And this is the working group for CINAM. And that would be all. Are there any questions? Thank you for your presentation, Itzel. And I would also like to thank the other institutes, INTI and INACAL, for their contribution